All right, okay, so here is our function. What we want is f of xy, yeah, like this. What does f of fxy mean? How do we get it? Okay, that means we need to differentiate first with respect to x and then with respect to y. And generally speaking, I think I mentioned that this is the same as differentiating first with respect to y and then x. The order is usually not important. So here, but technically, yes, we need to find fx first. So you need to find fx and then fxy. Yeah, so that's how you do this. So first differentiate with respect to x. So give it a try. Try it. Every question, we'll give it 5 minutes or so, and then we will solve it together. Can you please put your name and ID here? Okay, so let's see then what's happening here. How would you find fx? how do you find the derivative with respect to x? What can you use here? Anyone did it? Yes. The quotient rule, yes, you can use the quotient rule. Perfectly fine to do that. You can use the quotient rule. There are other ways, but quotient rule is maybe the easiest. So using the quotient rule, assuming you call this u and this is v, so it's u dash. What is u dash? Not 1.
Why? 0.
0. We are differentiating y with respect to x. Y is a constant with respect to x. So it's 0 times x minus what? So u dash v minus u v dash. What is the derivative of x with respect to x? 1. Yeah? 1 over x squared. Perfectly fine to do it this way. So the final answer here, minus y over x squared. This is fx. Now you take this fx and you differentiate it with respect to y. What rule can you use again? The quotient rule. Fine, no problem. So try it. Try the quotient rule again with respect to y this time. Yeah? And see what the answer will be. Sorry? Yes, you can. Yes. So we'll solve it here. Maybe we will not have time to do all the questions, but you can solve it again. Just to make sure you're okay with this, and your test will be very similar to this. As always, it's going to be similar. Now we differentiate this with respect to y. Okay, so in this case, you will have, what is u dash? 1, yeah? 1. V is x squared minus u. What is v dash? 0 over x squared like this. So in the end, this will be 0. So you will see that you will get minus x squared over x to the power of 4. So in the end, the final answer is minus 1 over x squared is perfectly okay. So the correct answer is C here, yeah? C is the correct answer.
How we get the final answer? Minus 1 over x squared.
Sorry?
How we get the final answer? Minus 1 over x squared.
X squared, x4. So what do you do with the powers?
Okay,
yeah? 4 minus 2 is 2, yes? Like this. Okay, great. Any question regarding this? No? Oh. Let's take a look at this one now. You want to find the critical points of this function. So go ahead, try it. Go back to your notes, check how we did these questions. Search, and I will give you 5 minutes or so again to try that. So you want the critical points of this function. So here our function so you want to find the critical points. How do you find critical points? Fxy? Table. No. We could try anyway. It's not finding the critical points does not involve the table. Table, when do we use that table? To classify. Who said classify? Yes, to classify. To decide whether a critical point is a local maximum, local minimum, or a saddle point. Yes? Then you need to use that table. But before the table, we need to find the critical point. How do we find that?
Derivative versus x minus 1.
Yeah, what do we do with these derivatives?
Then equal to 0.
Equal to 0, yes. You need to solve fx equals 0 and fy equal to 0. That is what critical points are. These are points where fx is equal to 0 and also fy should be equal to 0. These are how do you get the critical points. So write fx and solve it equal to 0. Fy equal to 0. Can you write? You did it? Finished? Okay, good. You can, if you've done this, you can try the next one, which is find the equation. So look at your of the tangent plane at the point. So try this. If you've done this, try the next one. All right. Anyone else did it? Are you done? No? Yes. What happened to the 0? Put equal 0. So each one. So each one. There are two equations, basically. You will see two equations. You need to solve them. What is x and y which satisfy these two equations? You have any papers? Okay. So fx. What is fx here? Okay. So you will say fx. What is the derivative? So fx equal to 0. That means what? What is the derivative with respect to x? 2 minus 2x must be equal to 0. That means x is equal to 1. That's it. First. Second, So we know that our critical points, their x coordinate will be 1. That's the first thing. Now, what is the y coordinate? Let's see. We will get it from the second equation. Fy. What is the derivative with respect to y? 3y squared minus 3. And you put this equal to 0. Now you solve this. It's up to you how you solve it. You can use mod 5(3) in your calculator. You can put 3 as a common factor, which means y squared minus 1 is 0, which means y is equal to plus or minus 1. Plus or minus 1. Okay. So that means the critical points, how many are there? 2 critical points. 1 and 1 and 1 and minus 1. That's it. That is the solution to this. Is this difficult? Please, girls, wake up a little bit. Make sure you do some work. Nothing comes without work. And if you just feel you can sit back and just get the grades without working, it doesn't work like that. You need to work a little bit. Review. Make sure you... So here, what is the right answer? A, B, C, or D? B, yeah? B. 1 and minus 1 and 1 and 1. So B is the correct answer. Any question regarding this? So first, fx equals 0. Solve it. This gives us x equal 1. Then fy equals 0. You solve it. You get 2 values of y. And then the critical points are given like that. Okay, now let's move to the next one, which is this one. I want you to have a look. At the end, I will put this on Blackboard. I will post these solutions on Blackboard. You can review that. You can check. All right. So here you have a surface which is z equal x cubed minus 2xy, and we want to find the equation of the tangent plane to this surface at the point 1 minus 1, 3. There is a rule for that. You can find it in your notes. If you have any notes somewhere, you can see the rule for finding the equation of a plane tangent It's okay, it's okay. I will take it. Okay, now, does anyone have the rule here? Anyone found the right rule? Yes, yes. And then? Then we get x of y. Yes, basically, yeah. Okay. So the rule you have here is equation of a tangent plane. Will be fx, yeah, at the point ABC, yeah, multiplied by x minus a plus fy at the point ABC multiplied by y minus b, and then plus fz at the point ABC multiplied by Z minus C equal to 0. This is the equation of the tangent plane at the point ABC, yeah? At the point ABC. What is ABC here? What point are we looking at? Yeah, 1 minus 1, 3, yeah? 1 minus 1, 3. So now you need to find the fx, fy, and fz. This will come from the equation of the surface. Z equal to x cubed minus 2xy. Now bring everything to the left side. You will get z minus, or let me take z to the other side, yeah? I think it's better to do it this way. The result will be the same, by the way, it doesn't matter. But I prefer to do it this way. X cubed minus 2xy minus z equal to 0. Now, let's find these three things. This, and this. So can you complete this, please? So you need to find fx at the point ABC. You need to find fy also at the point ABC and fz, and then you just substitute in the equation. This will give you the answer. What is fx? Yeah, 3x squared minus 2y, yeah? So therefore, fx at the point 1 minus 1, 3 will be 3 times 1 squared minus 2 times minus 1. So the answer is 5. Good. And then you do the same thing with fy. And the same thing with fz. Okay, so what is fy? Minus 2x, yes? Minus 2x. So that means fy at the point 1 minus 1, 3 is minus 2. Okay, good. And finally, fz is just minus 1, yeah? So that means fz at 1 minus 1, 3 is minus 1. Okay, great. Now, that means, so, the equation of the plane of the tangent plane, maybe, I should say, yeah. Oh, okay. Is 5 times x minus 1 minus 2 times y plus 1, and then minus 1 times z minus 3 equal to 0. Now, if we look at the choices here, you don't see that, yeah? If you look at these choices, you don't see it. So that means you need to work a little bit more here. So you need to open these brackets and simplify. So it's going to give us 5x minus 5 minus 2y minus 2 minus z plus 3 equal to 0. So 5x plus 2y, no, minus 2y, yeah? Minus z equal to 4, yes, equal to 4. Okay, now, I think there's a problem with this, yes? Yeah, I think there is a, yes. Okay, I think there is no correct answer there. It's basically the first one, but with a minus 4. So it's this one, but with a minus 4 here. Yeah. So this one, but please make a note that it should be minus 4, not 4. Because this, you can change this, of course, by changing all the signs. You can change this into minus 5x plus 2y plus z equal to minus 4. This or this. So I will change this. It's actually minus 4 here. So yeah, I will change this. Yes. Are we okay with this one? Yeah, you know the way you need to solve this. So first, make sure the equation is something equal to 0 for the surface. And then you find fx, fy, fz, and then use this rule that you have here. This will give you the equation of the tangent plane at the point ABC. Are we okay with this? Yeah? So I need to change this answer. Okay. Any question regarding this? Was this okay? Yeah, please remember the rule. Then you will get these questions in your test, basically. That's what I'm telling you. So please make sure you review and do them properly. Yes?
Studying from this example is enough.
Sorry?
Studying from this example is enough.
I think so. I think 90% or maybe 100% of your test is here. Do you understand?
Like, can we get full mark if we just study from here?
I think so, yes. I think so. Yes. I think so. I'm not saying don't study other things, but focus on this and you will be more than okay. Yeah. So anyhow, Now, find the equation of the tangent plane. This is the same thing, yeah? So second question, just to make sure you're okay with this. So can you try it now? See if you, I hope there's no mistake in this one.
Same idea.
Sorry?
The same idea as the previous.
Same idea, yeah. Find the equation of the tangent plane. That's exactly the same, except this time the surface is a bit different, yeah. But exactly the same idea, yeah. Are you done? Is there a correct answer here? Okay, good. If you want to try the next one, you can try this one, the level curves. Okay, so let's do this one because it's actually very similar to the one we did before. If you paid attention, you will be able to do this very quickly. So, what's the first step? What's the first step here? Make the whole equation equal to 0 by maybe moving this here, yeah? It's up to you. Maybe this, maybe that. It's up to you. So you get this equal to 0. Then what do we do? Number one, fx. Yes. What is fx here? Minus 2x. خلاص, very easy. fx at minus 3, 4, 5 will be minus 2 times minus 3, 6. Then fy. What is fy? Minus 2y, huh? So fy at the point minus 3, 4, 5 is minus 8, yeah? Or negative 8. And finally, fz. What is fz? 2z. So fz at the point minus 3, 4, 5 is minus 6. Sorry, 10. 2 times 5, so 10. Okay, good. Which means now I can write the equation. What will be the equation? fx times x minus x plus 3. Yeah, minus 3 plus 3. Minus 8 times y, yeah, times minus 4. And then plus 10 z minus 5 equal to 0. Again, I don't think we see this, this form is not here, so you need to open these brackets and simplify. So you will see 6x plus 18 minus 8y plus 32 plus 10z minus 50 equal to 0. So we can write this 6x minus 8y plus 10z. And you can see now the numbers 18 plus 32, 50 minus 50, 0. So there is no numbers. So we can write this equal to 0. So that means the solution is this D here, and that is our correct solution. So please remember this, not really difficult, please. Yes, you should be able to cope with this here. That's not a very difficult kind of question, so please remember this. You will get this, believe me, you will see this in your test, yes? So please make sure you know how to do it. Okay, now 6 is a very simple one regarding the level curves. Here there are no calculations. Do you remember what level curves are? How do we find the level curves for a function? So you have a function f of xy, x squared plus y squared. I want to find its level curves. We talked about this briefly in one of the sections. How do we find the level curve? We make the function f of xy equal to c. We make it equal to a constant. And then see what is this shape. What shape will you get if you put f equal to a constant? So here, this question on level curves. If you remember the rule of level curves, the definition, then basically level curves are given by f xy equal to a constant c. So in this case, what is f of xy? x squared plus y squared equal to a constant c, where c here has to be a positive number, like 1, 2, 3, 4, 5. What are these? What are these equations? For example, x squared plus y squared equal to 4. What is it? Is it a circle? Is it a parabola? Is it a straight line? Is it a sphere? It's a circle, of course, yeah? X squared plus y squared is a circle. So the answer here is circle. If, let me just, I will come back to your question. Suppose your function was, let's say, 3x plus y, and you want to find the level curves for this function. So the level curves will be 3x plus y equal to a constant. What are these equations? Straight lines, yeah? 3x plus y equal 10, 20, minus 5. These are straight lines. So you will have many straight lines. Whereas here, circles of radius depending on c. Yeah? If c is 4, for example, the radius will be 2. If c is 9, the radius is 3, etc. So here, circles. Here, lines, straight lines. Like this. Yes, what's your question?
We have Z, and then it's going to be a sphere, right?
Sorry?
Z square.
If you have, no, this becomes a different question. This is into, there is no Z here. Yes, you will not get Z in this kind of question. If in 3 dimensions, I could give you f of x, y, z. I think we did something like this before, plus y squared plus z squared. Here, the level surfaces. Here we talk about level surfaces, not level curves. These are surfaces. So x squared plus y squared plus z squared equal to c. What is this shape? It's a sphere. Yes, it's a sphere of radius square root of c, whatever the c is. So if you have a function with x, y, z, then like here, then the level, we're talking in that case of level surfaces, not level curves. Do you understand it? Yeah. So it's like this. Yeah. Okay. So that is this question, just general. Okay, let's try about this one. Of course, like all the questions, there are rules for every question. Do you remember the rule here? How do you find the maximum rate of change of a function at a certain point? Yes. Yes. It's basically the magnitude of the gradient. Yes? You find the gradient, which is fx, fy, and you get the magnitude of the gradient, that will be the maximum rate of change of the function. Yes? So that is the rule for this function. So the idea basically here is that you have a function which is defined. What is the domain of this function, by the way? Because if I asked you to find the domain of this, where is this function defined? R squared, yeah, in the whole plane. This function is defined everywhere you want on this plane. It will be defined. F at 1, 1 is okay. F at -1, 5. It's defined all over the plane. But we want to see what's happening at the point -1, 1, yeah, somewhere here. At this point, -1, 1, the function has a certain value. Yeah? What is its function? What is its value, by the way, at -1, 1? At -1, 1, it's going to be -2, sir. Yes? -2 or no? Yes. Yeah? So its value is -2 here at this point. And then, as we move in different direction, this function may be increasing in some directions, may be decreasing, etc. And what we know is that if you take the gradient of the function f, then in this direction of the gradient, that's where the function changes the most. That's the direction of the maximum rate of change. It will be, if we go in this direction, the function will be increasing very quickly. So, and its maximum rate of change, the rule says it's actually the magnitude of the gradient of the function at the point -1, 1. This is the rule that you need to use. So you need to find the gradient. What is the gradient? It's fx at the point -1, 1 and fy at the point -1, 1. So you need to find these two numbers, and then you find the magnitude of that vector. So first find fx, and then fx at the point -1, 1. Find fy, and then you take the magnitude of the vector fx, fy, which is the gradient function. So you can think of this as, don't know, 3 steps, 4 steps. So fx is 2x, yeah, that's okay. So this means fx at the point minus 1, 1 is minus 2. Please pay attention to this also. You will see this question definitely in your test. It's an important question. Fy is minus 6y, sir? Minus 6y. So that means at the point minus 1, 1, it's equal to minus 6. So that means the gradient of the function at the point minus 1, 1 is the vector minus 2, minus 6. So finally, we can write then that the maximum rate of change that we are looking for is the magnitude of the vector. That's the rule. And therefore, it's going to be the magnitude, the square root of minus 2 squared plus minus 6 squared. So that means the square root of 30. So 30, yes? No, 40, yes, 40, sorry. Which is, yes, square root of 40, which is the same thing as 2 square root of 10, yes. So, it's okay, square root of 40, which of course is 2 square root of 10, and that is the answer. Again, if you think about it, there is absolutely nothing difficult here. If you know the rule, this is very easy. So, you are looking for the maximum rate of change. Think of this. What is the first step? Fx, yeah? And Fx at the point that you are given. Second step, Fy. Fy at the point. Let's take the square root of this square plus this one square. That's it. Minus 2, even you don't have to write the gradient or anything. This minus 2 squared plus this minus 6 squared, the square root of that, that's the maximum rate of change. Does that make sense? Yeah? Okay. So please, just remember that. That's not a big issue. Okay, this one. Okay. The chain rule, a bit of a pain this one, but we can have a look at it. So what we have here is a function f of xy, which is given by x, e, y. But x itself is a function of t, which is square root of t, and y is t to the power of 3. So in the end, the function f itself is a function of t, yeah? Because it's a function of x and y, and each x is a function of t, y is a function of t, so in the end, f is also a function of t. Now, the derivative of f with respect to t, I think by the chain rule, it's, let me remind you how do we get this? It's df over dx multiplied by dx over dt plus df over dy multiplied by dy over dt. So that's what the chain rule says. Now, So how many things we need to calculate here? 4. Yes, we have 4 things that we need to calculate. First, what is it? 1, 2, 3, and 4. So, df over dx. Look at the function f. What is its derivative with respect to x? E to the power of y, huh? Yes, because it's x e to the power. So this is e to the power of y. Now let's immediately use y equal t to the power of. So this will give us e to the power of t cube. Halas, number 1. Number 2. Dx over dt. Look at x. Square root of t. What is its derivative with respect to t? 1 over 2 square root of t. So this very famous rule from calculus 1 or even before calculus 1. You may have known this before. Okay, so that's okay. Right, let me just replace this arrow by what? Equal, yeah? Just equal. Number 3, df over dy is, yeah, xey. It's okay. So now we substitute everything. So that will give us square root of t e to the power of t cubed. And finally, dy over dt. What is dy over dt? 3t squared. Now let's take all these 4 things and use them here. Remember, the question is to find df over dt. You see the question here. What is df over dt? So df over dt. This. So let's substitute now, and then we will be fine. So df over dt will then be equal to e t to the power of 3 multiplied by 1 over. Is that okay? Yeah? Plus df over dy, which is square root of t e t cubed multiplied by 3t squared, like this. Now let me put e t to the power of 3, because I cannot see this expression here. So I'm going to put e t to the power of 3 as a common factor. So then it will be 1 over 2 square root of t plus 3t squared square root of t, like this. And I think you can see now that the answer is C. So you can see that this is exactly what is given here. So we say this is the C. Was that okay? Yeah. Again, the rule, very important here. You need to memorize it and then find the 4 things, 1, 2, 3, 4, and then substitute here. And don't forget that when you have EY, you need to replace this Y with T to the power so that you get everything as a function of t. Yes, we need the final answer always as a function of t. So then we will be okay. We get our answer without too many problems. Okay. Any questions regarding this? Okay. Now the directional derivative. I think we did many questions like this in class. Yeah. So we have a function f of xy. I want to find the directional derivative of the function f at the point 1, 4 in the direction of the vector 2, 1. Okay. Do you remember how we did this? What was the first step we did? So I want the derivative of this function in the direction of the vector 2, 1. So this function is defined at the point 1, 4. Point 1, 4 here. And I want to find its derivative in the direction of the vector 2, 1, which is a vector like this. This is the vector v equal to 2, 1. So I want to know how is this function changing in the direction of the vector 2, 1. Is it increasing, decreasing, etc. So I want its derivative in that direction so that I can get the rate of change of the function. Now, there is, again, some steps. I don't know whether you remember them or not. What's the first step? Sorry? fx and fy, yeah, that could be the first step, yes. So we can get fx, yeah, at the point xy in general. So here, what will be the fx? Look at the function, yeah, look at this function. You want its derivative with respect to x. So this is of the form e to the power of u. What is the derivative of e to the power of u? Yes, so it's u dash, derivative of u, multiplied by, yeah, e to the power of u. Derivative is derivative of u multiplied by e. This is very famous, very important rule in calculus. You need it. Now, so here, what is the derivative of u here with respect to x? 8x, huh? E for x squared minus y. And I want this at the point 1, 4. 1, 4, yes. So I need to substitute. If you substitute x with 1, y with 4, the u, it becomes 0 there. Yeah? So it will be, I think, 8. So, can you see that it's going to be 8? 8 times 1 times e to the power of 0. Yeah? 8, 1, e to the power of 0, so 8. Number 2, fy. Okay, good. Fy. This time, the derivative will be minus 1, huh? Minus 1. So it's going to be minus e, no need to put the 1, yeah, it's just minus, like this. So that means fy at the point 1, 4 is minus e to the power of 0, so minus 1. Good. All right, so we have done 2 steps. What's the next one? Anyone remember? Sorry. multiply by the vector, dot product with the vector. But before this vector, we need to do something with it. Find the unit vector, very important. In the direction of V. So it's important to find the unit vector now. Unit vector in the direction of V. V is 2, 1, huh? 2, 1. So the unit vector U will be 1 over. You remember how to find the unit vector? I hope you do. It's 1 over the magnitude of V. What is the magnitude of V? Square root of 5. Very good. Times 2, 1. So it's going to be 2 square root of 5, 1 square root of 5. Now we have 4 numbers, and we can say then, so final step, the derivative of f in the direction of the vector v or u, it doesn't matter, you can, at the point 2, 1, will be 8 times what? 2 over square root of 5, yeah, plus minus 1 times 1 over square root of, very good. Okay, thank you. I'm happy to see that some of you remember these things. After this, you just do your calculation. Yeah. So 8, yeah, if you take your calculator, I think 3 square root of 5, is it 3 square root of 5? Yeah? 3, take your calculator, calculate this, and I think you will get 3 square root of 5 is that answer of this thing. Are you okay with this? So that's how you find the directional derivative in the direction of a vector v, yeah, which is given to you like this. By the way, the vector v could be, instead of giving you directly the vector, I could say in the direction of the vector from this point to that point. Will you know how to do that after? So you find the vector by subtracting, yeah. So if I give you a vector from the point, let's say, what is this point? Is 1, 4, huh? To the point 2, 5, say, then the vector v will be 1, 1, 1, yeah. And then you do the same work, find the unit vector u, etc. So the vector can be given as 2 points from A to B or P to Q. Then you need to find the vector v, and then you do the same work as we did here. Are we okay? Still okay? Can we do a few more? Maybe 10 minutes more or so? Okay. Now, here is classifying now. Now, we want to classify basically a critical point. So, this function, let's check first of all that 1, 0 is a critical point. So, this time we are going to find the critical point and classify it using the table. Do you remember the table? Yeah. So first, let's find the critical point. This session is really important. What we are doing today, if you are interested in a good grade in test 2, this is really important. So you need to review this. and make sure you do these questions again and again until you understand them properly. The function f has a local minimum, or a local maximum, or saddle point, or maybe it has no critical points at all. So, are you done?
Yes.
Okay, good. Okay, can I just tell you something? I might send an email, but before I forget, I will not give 13.1 is removed from the test. So no integration in the test. Okay? So just focus on chapter 12, and that's it. So no integration. I send an email, but just in case I forget to do it. So you can ignore if you want. There are two questions I think on integration here. You can ignore them. Okay, so are you done? Anyone else has done this question?
Yes.
Have you done it? Are you done? No. Right? Advancement? Can you provide the reason why you get? Yes. Sorry? So the one? Okay, let's check it. I'm really not sure. So what do you think? So you get the 1.0, and fx6 is fx1. Oh, fy1, yeah, fx1 is fy1 is minus 6. So that means the d, this comes as minus So, anyone else with this question? Have you done it? Yes? No? Have you done it? You're not sure? All right. Have you done it? Right. Okay. Let's see that. First, there are two steps, of course. First, we need to check that it is really a critical point. And then when we know it's a critical point, we classify it using the table. Okay, so critical point means the two partial derivatives are equal to 0. So x squared minus 3y squared minus 2x. So fx will be 2x minus 2, and this should be 0. That means x is equal to 1. So number 2, fy derivative is minus 6y equal to 0, and this only happens when y is 0. That means there is only one critical point for this function, one critical point, which is 1, 0. Okay, so that is a critical point. So already we can say that D is not the correct answer, yes? No critical points, no. There is a critical point. So D, definitely not the right answer. Now, I want to classify this critical point. I want to classify it. And to do that, I need the second derivatives, fxx. So you need to go here. It's 2, yes? Yeah. Fyy, you need to go here, minus 6. And fxy is 0. You can go to fx and differentiate it with respect to y, or you can go to fy and differentiate it with respect to x. So you will see that you get these numbers. After that, it's just a matter of that small table. The critical point is 1, 0. fxx 2, fyy minus 6, fxy 0. So the D, remember D, how do you get D? Very important. You need to know these rules, yes? It's fxx fyy minus fxy squared. This is the D, the discriminant. Okay, the D here is minus 12. And because it's negative, negative, that means what conclusion can we draw? It's a saddle point. So saddle, this point is a saddle point. Not a maximum, not a minimum. It's a bit like when you have the function x cubed. At this point, its derivative is 0 and all that. It's a critical point, critical value, but it's not a maximum and it's not a minimum. So basically, it's a saddle point. So here, the answer is the C. Okay, let's finish with this question 11. So you have a function G like this, and we want to find its domain. Now, do you remember what the domain, how we can get the domain? Okay. Yes. Basically, when you deal with domains, there are fractions. When you have fractions, then whatever is in the denominator should be not equal to 0 or different from 0. Yeah. For example, if I give you this function, so there's just a little bit of a review, and I want to see what is the domain of this function. Yeah. What is its domain? You will say this domain is this function is defined everywhere on the xy plane, except when x minus y is equal to 0. That means y equal to x. So that means this function is defined everywhere except on this line, except on this line, y equal to x. So the function is defined here, it's also defined here, but it's not defined on the blue line. Do you understand? Because on the blue line, can you give me a point on the blue line? 0, 0, yes. Is this function defined at 0, 0? No. Another point? 1, 1. Is this function defined at 1, 1? No. So this function is defined everywhere except on the line y equal x. So the domain is the whole of R2 except the line y equal to x. That's what happens with fractions. Now, another big result we mentioned is when you have square root. Yeah. If I give you a function like this, square root of, let's say, x squared, okay, let me just, plus y squared minus 4. What is the domain of this function, f of xy? Because of the square root, because of the square root, when is the square root defined? Yeah. What is inside should always be greater than or equal to 0. That means x squared plus y squared minus 4 must be greater than, otherwise this function has no value. The square root of a negative number is nothing. So that means x squared plus y squared is greater than or equal to 4. What does it mean? Where is this region? What is equal to 4? First of all, if you put x squared plus y squared equal to 4, what is it? It's a circle, yeah? Circle of radius 2. Greater than or equal to 4, is it outside the circle or inside? Outside. This is the domain of our function, outside the circle. Yes? For example, if you take a point inside, this function will not be defined. For example, at 0, 0. Try to find f of 0, 0. Can you? No, because 0, 0 minus 4, square root of minus 4, nothing. So this function is defined outside the circle of radius 2. So that's the general idea regarding. Now, here, this function consists of two square roots. The first one is a bit like this example. So this top will be defined outside the circle of radius 3. Okay? And this one, so that means, yeah, for this question, you will say x squared plus y squared minus 9 must be greater than or equal to 0. That's the first condition. The second condition is 4 minus x squared minus y squared must be greater than 0, not equal to 0, because why I'm not putting equal to 0 here? Because it's in the denominator. Something in the denominator, can it be 0? No. So anything in the denominator should not be equal to z. So we solve these two things together. So x squared plus y squared must be greater than or equal to 9. And x squared plus, if you move this to the other side, what? Sorry? We could put 40 the other side? We can, but then you will have minus x squared minus y squared greater than minus 4. And you need to multiply everything by minus 1, which means that you need to change the inequality. It's okay. But actually, this question has a problem. Because x squared plus y squared must be greater than 9. And it must be also less than 4. So that's not, it's not possible. So there is a slight problem with this question. So according to this, it's A, yeah? X squared plus y squared must be less than 4, which is this, and x squared plus y squared greater than or equal to 9. But actually, can you have this at the same time? Something less than 4, but at the same time greater than 9. Is that possible? No. So I want to put this 4 here and this 9 here, then it will be okay. So yeah, there's a slight problem with this question, actually. But the answer, basically, you can see that we must have this and this for this function to be defined. But actually, we cannot have these two at the same time. It's a bit like saying a number is less than 4, but it's also greater than 9. Can you have a number less than 4 and greater than 9? Not possible. So this question, I will change it a little bit. So next time you visit this test, you will see a slightly change in this question. Okay, girls, I want to say thank you very much for your hard work today. This is a really important session. Thank you for coming to class. And please come to class next week also. And you should be okay. Any questions at all? Anything you want to? Okay. So please review this and you will be fine. And have a nice day. Okay, thank you. Okay, bye. Okay, bye. You too, thank you, thank you. Okay, so you want to do the test now? Huh? Yes? Okay, bring your laptop.
Thank you, Dr.
Okay, have a nice day, thank you. Okay. Okay, instructions. Third. Can you open your go to tests, please?
From the phone browser.
Sorry?
From the laptop browser.
Yes, you do need to do that, yes. Is the tester? There's a password, so you need to enter it. Calculus 2, test 1. All small letters. No space.